Okay, guys, today we are going to put some things together. So we've been working on equations and tape diagrams. Of course, we've done word problems as we've gone through all the concepts this year. And so today what we're going to do is we're going to put some of those things together. So what we have here is we have 4 word problems and 4 tape diagrams. So one of these tape diagrams matches one of these word problems, and they're all scrambled up. So our job is to figure out which word problem matches with which um, tape diagram. So the first thing I want to do is I kind of want to go over the tape diagrams and just see what they're telling us. So let's look at A. So I'm down here with A. And it says that there's a 4 here, and there's an X here, and that when I put the 4 and the X together, they are equal to or as much as 12. That's what A is telling me. So I think A is telling me that this is for an addition problem. Okay, so I'm just going to write add there on A. We think A is for addition. Let's look at B. Now B is a little different from A, isn't it? B has a bunch of X's. Now, this tells me right off the bat it's multiplication, and let me explain to you why. Because multiplication is the same as repeated addition. In other words, if we are adding the same thing over and over, it's much easier to say 4x or 4 times x than it is to say x plus x plus x plus x. So this to me, because we see the same thing repeating, this is a multiplication problem. And when we multiply that x times 4, we end up with 48. So I'm going to write an M for multiply. Okay, let's look at C down here. So, I see an X and I see a 12, and it looks like we're kind of combining those. Are we combining them with addition or multiplication? Because both addition and multiplication combine things, right? So it looks to me like it's addition because I don't see more than one X. I see X adding with something else. Okay, so that must be addition. All right, let's look at D. Boy, that's a lot of X's there. Again, if I see X repeating itself over and over and over again, basically they're telling me we want X, and if we counted these up, we'd find 12 of them. We want X 12 times. So that's 12 times X. That's multiplication. Okay, well, now that we got that situated, let's go ahead and start to read the problems. Let's look at number 1. Jenny worked for 4 hours doing yard work for her neighbors, and she made $48. How much does she make per hour? Okay, so I'm picturing Jenny. I always like to draw a picture. It really helps me figure things out. So here's Jenny, and don't make fun of my art. And she's got a rake probably, right? And she's doing some yard work for her neighbors, okay? At the end of the day, they're going to give her 48 bucks. Well, that's cool. So I know that's the total. That's as much as she made. So I'm going to write equals 48 over here. Now, what are they asking us to look for? They're saying, how much does she make per hour? So in other words, how much does she make in 1 hour? Well, they don't tell us that, right? That must be our X. Whatever this question is asking, whatever the unknown is, that equals the X. Okay. So she worked for 4 hours. She made a certain amount of money every hour, but I don't know how much that is. So I'm going to draw 4. Like that's an hour. That's an hour. That's an hour. And that's an hour. So it says she works 4 hours. Altogether, she made 48, but how much does she make per hour? We don't know how much she makes per hour, right? So I could just put a question mark there. But in algebra, when we don't know something, what do we use? We use a variable. Okay, so I'm going to put a variable there. Okay, so now that I've drawn it out, like this is what I see when I read the question, and I know that I'm looking for how much does she make per hour, it looks like one of these tape diagrams, doesn't it? It doesn't look like A. It sure does look like B though, because there's 4 X's, and I have 4 X's, and the total here is 48, and the total here is 48. So I'm going to say that question number 1 really works with the diagram that is B. Let me just get all this stuff erased here. So I think I'm just going to move the question above the tape diagram. So let me get that situated here. This one is not correct. This one is. Okay, so that one matches. All right, so we got 1 down, 3 to go. All right, let's look at number 2. Ricky rides his bike 12 miles every day. He took a break this morning at the park, which is 4 miles from his house. So how much further does he need to ride to finish his ride? Okay, so again, I'm going to draw this out. Here's Ricky. Oh, that's a little thick. Here's Ricky, and he's on his bike. Don't make fun of me. So you get the idea. He's kind of on his bike. Okay, he's on his bike. And he's going to ride 12 miles today. There's a 12 miles. He took a break this morning, which is 4 miles from his house. So he's only ridden 4 miles. So 4 is less than 12. I'm just going to represent it like this. And I'm going to say that's a 4. So what are they asking us? They're asking us how much further does he need to ride to finish his ride? And we know his ride is going to be 12, but he's only gone that far. Well, he needs to go this much further. And we don't know how much that is. So I'm going to call that X. Okay, so take a look at the tape diagrams and see which one do you think fits. When I look at D, I know that that's not it because that's multiplication, and we clearly have some kind of an addition problem here. But is it going to be A or C? Because I see a 4 and a 12 in both of those. Well, it comes down to what are we looking for? So we know that 12 is the total. The whole ride is 12. In this diagram, the whole length is 12. In this one, in C, the whole length is 48. It doesn't say he's going to ride 48. He says he's going to ride 12. So I am thinking that number 2 goes with diagram A. So that's what I'm going to say. I'm going to erase all my beautiful artwork. And I'm just going to pull number 2 right down here. Okay, so we have 2 more to go. And I'm going to choose green for the next one. Okay, number 3. Aisha is making goodie bags for her party. She has 48 items, and she's going to make 12 bags. So how many items are in each bag? Okay, so I'm kind of picturing her like, and she's got a bunch of items. I'm not going to count 48, but I'm just going to estimate. So she's got a bunch of items. Here's my 48 items, and it says she's going to make 12 bags. So I'm going to draw 12 bags out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. She has 12 bags. And we're asking how many items are in each bag. So we don't know. And when we don't know how many items are in the bag, what do we use? Well, we use a variable. And I bet you can kind of already see how this looks a lot like one of our tape diagrams, doesn't it? Okay, so the point is she's going to be putting all of these items into the bag. She's got 48 here. So the question is saying, well, if she's got 48 and she kind of splits it up into each bag, how many items will go in the bag? Okay, so clearly, if you look at this and this, they're very similar. And in fact, it does say the total is 48, and we know that she has 48 items. So these match up. So I'm going to go ahead and get rid of all my lovely, lovely artwork. I really do encourage you guys to draw things out. Just make a little sketch. I mean, you can actually draw little stick figures and people if you want, but you could also just draw little items or make tape diagrams as you go to kind of help you figure it out. Okay, so last problem. We only have one problem left, so I'm hoping that 4 is going to match up with C, but let's make sure. Okay, Rissa needs to read another 48 pages of her novel this weekend to keep up with her English assignment. So the total that we're looking for is 48, and in fact, that works because our total down here is 48. She has read 12 pages on Saturday. She's already read 12 pages. Okay, well, that seems to work because here's a 12 down here on this diagram. How many pages will she need to read on Sunday? Well, it's saying she's read this far. She needs to get all the way to 48, and she has this much left, and we don't know how much this is. So I would say for sure that that matches up with this problem. Okay. So I hope that's helpful. You'll have an assignment where you'll have a chance to do the same thing, kind of match up some word problems with tape diagrams, and I will ask you to take it a step further and actually solve them as well. All right, if you need any help, make sure you get a hold of me. You can email me. You can come by office hours. I'm here to help.